Historically, Muslims worldwide have used several orientation methods to find the bearing to Mecca, the holy city of Islam and the center of the Muslim world. For this project, our team tested some of these methods in an effort to find the correct bearings from Cambridge and Boston, Massachusetts, to Mecca in Saudi Arabia. Our goal was to test how accurate these methods are, both through calculations and through visits to mosques located throughout Boston.
Coming together and facing in one direction is significant in terms of Muslims as a unified global community.
There are a few key terms that it's important to know to understand our project. First, the Qibla, which is the direction of Mecca and specifically of the Kaaba. Second, the Mihrab, which is a notch in the wall of a mosque that points to the Qibla. And third, the Kaaba, which is a cube-shaped building in the heart of Mecca. Prior to the 9th century, the direction of the Qibla was not found by computation. Rather, it was based on tradition. For instance, the Prophet had prayed facing south, so many Muslims imitated him and prayed facing south, regardless of their geographical location. Others merely prayed in the direction in which the mosques faced, because these early mosques were converted buildings from other religions. Already in the 9th century, Muslim scholars had begun to derive exact solutions for the direction of the Qibla using the Greek analemma, which it proved that Arab astronomers were way ahead of the West in terms of the use of the Great Circle method. In fact, Western navigators didn't figure out that great circles were different from rhumb lines until the 1500s. Another important innovation to mention in discussing Arab astronomers' works on the Qibla direction is Al-Khalili's table from the year 1375, which displayed the Qibla for latitudes and longitudes of 44 locations in the Middle East and is remarkably accurate. It used the spherical triangle method, which is related to the Great Circle method.
3 other methods have been used to calculate the Qibla: astrolabes, Greek analemmas, and solar observations. Every year, on May 28th and July 16th approximately, the sun passes directly over Mecca at noon. The direction of shadows at that time is the Qibla bearing. In modern times, many Muslims use websites like the online Qibla calculator.
Our question became, which method is more accurate for determining the Qibla direction, the rhumb line method or the Great Circle method? We also wanted to see if we could figure out which method mosques in Boston used when they were constructed.
All methods have some degree of inaccuracy. There is some debate among Muslim scholars about whether the Qibla is the Kaaba, the sacred mosque around it, or the city of Mecca as a whole. Even the method most commonly used today, the Great Circle method, is not completely accurate since the Earth is not perfectly spherical. Extremely old mosques are often inaccurately oriented because the old methods of determining longitudes were very inaccurate. Sometimes mosques are oriented based on tradition. For instance, in Egypt, Muslims have historically sometimes used the azimuth of the rising sun at the winter solstice for the Qibla, even though this is about 20 degrees off the correct Qibla for Cairo.
Historically, there has been debate between relatively secular astronomy and geography and Islamic sacred geography, which placed the Kaaba in the center and divided the world into sectors around it. The question is whether to use the rhumb line method and view the Earth as if it is a flat plane by using a Mercator projection, or to use the Great Circle method, which takes into account the spherical nature of Earth.
Using the rhumb line method, the North American Qibla is southeast. The rhumb line would be a straight line on a Mercator projection, which assumes a flat Earth, but it's actually a spiral on the real three-dimensional Earth. Using the Great Circle method, the North American Qibla is northeast. The circle goes between 2 points on a sphere called antipodes. On a sphere, the shortest distance between 2 points is along the Great Circle between them.
Based on our research, we predicted that the Great Circle method would be more accurate than the rhumb line method. To test this, we went to 3 different mosques in the Boston area.
Due to time constraints, we were unable to visit the Yusuf Mosque, Masjid al-Dawa, and Masjid al-Quran in person, and used Google Earth for measurements.
At each mosque, we took a compass reading based on the orientation of the mihrab to determine the Qibla direction used at that mosque. Later, we looked up the coordinates of the three mosques and the Kaaba on Google Earth. To test the rumline method, we plotted each mosque and the Kaaba on a Mercator projection. The straight line between them is the rumline. To test the Great Circle method, we used another online program that drew the Great Circle between the 2 points and calculated the initial bearing. We compared these initial bearings to the bearings we calculated on the compass.
Our small sample size, as well as the wide range of error, make it difficult to draw significant conclusions from this data. The constraints of modern urban planning and development doubtless had an impact upon the design of these buildings. Many were repurposed, and often in commercial spaces. However, the Yusuf Mosque, which was specifically constructed as a mosque, has the second largest error in our sample group. On our part, some difference could be related to human error since we were using handheld compasses rather than more sophisticated devices. Regardless of this, there is always a degree of uncertainty in measurement. Through our measurements, we were able to glean the majority of mosques in the Boston area used the Great Circle method, or a related method, to find the Qibla, since they all point closer to northeast than southeast, as the rumline method would have indicated.